Today's lesson, section 6.6b, we'll be talking about the law of cosines still, but in that section we'll be talking about bearing. So bearing is something that's used in navigation for direction. It's an acute angle measured from due north or due south. So if you think about our unit circle, and then instead of degrees all the time, look at like one of these where the top is north, the bottom is south, the right is east, and the left is west. This is how ships and planes get from one place to another because there's no real roads. So they use bearing to help them get to the correct spot. Okay, so like looking at the one on the top left, I mapped out some angles so that we can talk about how they write them out. So look at where our red line is, our ray, for our terminal side. So the green arrow is marking out the angle that happens here. Okay. So the angle for this first one top left, since you're coming from the north, you would say north, and then let's say it's 30 degrees. Okay. So north 30 degrees. And since you're going, like you're in the quadrant with north and east, it's north 30 degrees east. Okay? Because you're going 30 degrees in the east direction from north. Is kind of how they're describing it to you. If you look at the one on the left, let's say that you have 50 degrees there. You're still coming from north. So north, 50 degrees. And then you're going in the west direction from north, so you say north 50 degrees west. Okay? Okay, so if we look down here, bottom left, so now your line is, your green arrow is coming from south. Okay? So we would say south and the angle 20 degrees, and then that would be going in the west direction, so it would be 20 degrees west. Okay? And then the other one is south and going to the right 40 degrees, and then it's going towards the east side, so it's 40 degrees east. Okay? So that's kind of the basics of what we're doing. Now this messes with like our normal unit circle thought where we're always starting from the initial side of the positive x-axis and then going around counterclockwise or clockwise. So you gotta re-engineer your brains for the bearing problems in that sense. Okay. Everything else from there, all our other trig identities and stuff will still apply for us that we can still use. It's just how we are getting our angles because we're talking about something different. Okay. So just know that when bearing, we have these kind of things going on. Okay. So now, bearing problems, you're going to have word problems. So, example 1 says the pilot sets out from an airport and heads in the direction north 20 degrees east, flying at 200 miles per hour. After 1 hour, he makes a course correction and heads in the direction north 40 degrees east. Half an hour after that, engine trouble forces him to make an emergency landing. So what we want to do is find the distance between the airport that he started at and his final landing point. Okay? Also, we want to find the bearing from the airport to his final landing point. Okay? Now, with these, drawing pictures is the best way of figuring out what the heck's going on. So you can draw little ones. So this is north, remember. Okay? So if I am going first, it said north 20 degrees east, flying at 200 miles per hour. Okay? And remember, also, it says after 1 hour. Okay? Then he makes a course correction. So for 1 hour, he's going to fly 200 miles per hour. So north 20 degrees east. So let's say 20 degrees there. Okay, so 200 miles per hour for an hour, just like it says miles per hour, so I would have gone 200 miles if I was him. Okay? Then they said that he made a course correction. So now instead of going north 20 degrees east, now he's going to go north 40 degrees east. And he says that he does that for a half an hour. Okay? And then the engine trouble forces him to land. So half an hour for 200 miles per hour would be 100 miles. Okay, so they try to give you some nice values here. Okay, so 100 miles. And that's his landing spot. So landing point. This should be the airport. Okay? So now they want to know that distance and then this bearing. So the bearing needs to be in the terms like north, blank, angle, and then the other direction. Okay? So that's kind of how they want you to write it, not just an angle measurement. Okay? So here, if I have this side, so side and another side, okay, I need to find something else to help me out. Now, because you have these two angles over here, okay, of 20 degrees and 40 degrees, this can kind of help us out to figure out what's going on. So if I look here, I'm going to use a different color. That angle in the green is the same as the 20. If you think about, go back to your geometry, because this is going to help you out a little bit. Geometry says that when you have parallel lines and there's a transversal cutting through them, so a line that cuts through both of them, then alternate interior angles, which is this angle with the 20 degrees and this angle, are equal. So that means that is 20 degrees. Okay? Also, you know that this one is 40. Now, if you completed this right angle here, that's going to be 50 degrees. Right? And then this one is 90 degrees because it goes from east all the way to south. So that is a 90-degree angle if you're thinking about your unit circle. Okay? So you actually know the entire angle in orange. Okay? So 50 plus 90 plus 20 gets you 160. Okay? So now we want to use our side angle side. So triangles that have side angle side would be used with our law of sines, our law of cosines. Okay? So I want to find the opposite side. We can denote that as C if we'd like. So C squared. We know the other side, so 100 squared. Doesn't matter the order. 200 squared minus 2 times 100 times 200 times cosine of 160 degrees. Okay? So now I can figure it out from there. Okay? So I get, so C squared equals, that'll be 10,000 plus 430,000 minus 2 times 100 times 200 will give me 40,000 as well. Cosine of 160 Okay? So now I can put these together a little bit. 10,000 plus 40,000 is 50,000. Okay, at this point I'll have to plug it into my calculator because I can't put any more like terms together. And I definitely do not know what cosine of 160 is in my head because that's not on a unit circle. So cosine of 160, make sure your calculator is in degrees. So I get 87,587.70483, something like that. Okay? Then I want to take the square root. Make sure you're leaving it in your calculator. Take the square root of that. Don't shorten it. So C is actually going to be 295.95, and that's in miles. Okay, so we found the distance from the airport to his landing point. Okay, now I want to be able to find the bearing. So what that means is I need to find out this angle from that side that's 200 to the side that's now, we know that's 295.95 miles. Okay, so to make sure we don't bring in the ambiguous case, we need to use our law of cosines again. So, since I now have this side, I want to know this angle, okay? Remember, that's opposite of actually the side that's 100. So let's try to find that angle. So 100 squared equals 200 squared plus 295.95 squared minus 2 times 200 times 295.95 cosine of, let's call it angle B, it doesn't matter. So here, 100 squared is 10,000. Got 40,000 for 200 squared. We already know what 295.95 squared is because you should leave it in your calculator. Oop. Okay, so that's where I got that. Now, 2 times 200 times that number is going to be 118,380.88 cosine of B. Alright, and then put 40,000 and 87,587 together. You get 127,000. Okay, subtract that to the other side. Okay, so 10, that gives me negative 117,587. Okay, so now we can divide. Okay, that gives us cosine of B equals 0.33. Then doing the inverse cosine gives us an angle of 6.64. Okay, and then from there, because you're going from north to this point, that's just that little crevice. So we need to add that 20 to it. So then we get a bearing of north 26.6 degrees east. Okay? Have fun.